All right, welcome back again. So today we are talking about a recap of 11.6. So in 11.6, we talked about properties of chords. Again, chords are segments within a circle that go from one end to the other, but do not go through that center. Okay, so we'll talk about properties of a chord. So we learned a few things about properties of a chord. Okay, so this is 11.6 review. We learned that an angle, an inscribed angle, equals half of an arc plus an arc. And I'm going to go over what these mean. So this is my first formula that I found out. I also talked about intersecting chords. Where my chords intersect or meet inside of my circle. Okay. Where it's segment times segment equals segment times segment. Again, I'm going to go over what that means again. Okay. Well, let's talk about those two. So let's talk about the first one. So the first one is to solve for an angle that is inside. Okay, so I'm going to draw some chords that I have in here. Okay, again, they do not have to necessarily be going through that center. Okay, so in this case, let's say I wanted to solve for this angle here. And these angles are actually the same because they are vertical angles. Okay, so let's say this arc was 36 degrees. Let's say this arc down here was 114 degrees. Well, I want to solve for that x, okay, or my angle. Well, based on number one, that formula that I have my angle, in this case my angle is x, equals 1/2, one of my arcs is 36, plus my other arc, which is 114. Okay, I can add the inside here, 36 and 114, divide it by 2 or times 1/2. I should get x to be 75 degrees. So this x here is 75 degrees. Okay, let's try it a different way. So in this case, I was given 2 of my chords. Well, what if I'm not given 2 of my chords? What if I'm given an angle and 1 chord? How do I get the other chord? Okay, let's say this part was 73. Let's say this part was 96 degrees. I want to solve for this part here. Okay, so again, I'm going to use that formula. Angle equals 1/2 arc plus arc. So my angle that I'm given now is 73, so it's a little bit different from the one we did earlier. Equals 1/2 my 2 arcs. One of my arcs is x, the other arc is 96. Okay, well, how do I get rid of that fraction? Well, I have to multiply both sides by the reciprocal, which is 2. Okay, when I multiply 73 by 2, I get 146 equals x plus 96. That 1/2 goes away. I can subtract that 96 over. I should get x to equal 50 degrees. Meaning, instead of this here, that x, this is 50 degrees. Okay, so that's one thing we learned about in 11.6. Okay, let's talk about the other part that we learned about in 11.6. So I have intersecting chords. So I'm going to erase all this stuff. Let's say I have intersecting chords. Let's say I got a chord like this. And let's say I have a chord like this. Well, what this formula says, number 2, so intersecting chords, which they do meet right there, so I know that they are inside my circle and they do intersect. Okay, so I can have a property. We did this part here times this part here. So the product of the length of one segment is equal to the product of the length of this other segment. Okay, so let's try some stuff out. So let's say I had 3 here. Say I had 4 here. 9 here, and X here. Okay, so if I look at my pink and my green, so pink and green make one chord or one segment within my circle. And then let's look at the orange and the blue. My orange and blue make one segment or chord inside my circle. Well, based on my second formula that I'm given in number 2, segment times segment equals segment times segment, okay? In this case, I cannot multiply these two and multiply these two, okay? They do not form one straight line, so my pink and my blue do not form one straight line. My orange and my green do not form one straight line, okay? So I have to go one that forms the straight line. So let's plug it in. So I want to solve for X, so I'm going to plug it into the colors that I know and based on what I labeled. So I have my pink times my green equals my orange times my blue. Okay, so this is what I have so far. Okay, again, because I have those intersecting chords and they meet inside of my circle, this is why I can use this property. Okay, so I can multiply. So I get 3x equals 36. Well, to solve for x, I got to divide by 3. X equals 12. So in this case, this equals 12. Okay, so that was the other formula that we learned in 11.6. Okay, so there's two formulas we learned in 11.6, all about properties of chords. Okay, one uses arcs and angles, the other one uses segments. Okay,